Okay, we've done a real rush through the key parts of the Python core library, and we've started to write pretty complicated programs already. Um, and now with a program like that, errors creep in. It's unavoidable. And what we have to learn here now as a next um, step is to debug and deal with errors. So errors is not something to be scared about. It's 90% of your experience as writing programs will be debugging and finding errors. So if you run this program here, it runs, it's fine, everything is good. But if we, and the most common thing is syntax, if we forget to close this here, for example, we will get an error. And what we need to do now is not be scared. This all looks very scary, but if this is quite informative, and Python has really improved in its way of handling and informing on errors, so we can find very quickly in line 53 there is an unclosed function call here, and we can go to line 53 and just close it. So this is pretty simple, and if you run this, it will obviously run again. So let's first deal with just this type of errors and how to deal with them. And what you need to do is really start to really like these error messages and not just shy away from them and panic, because there's a lot of useful information that helps you deal with the error and debug it. So the traceback is the most important bit, which tells you where things happen, and it is a hierarchy of errors. So often one error triggers another error in another function or in another imported module. So the last one here is what you really want to look at. The last one is usually the one that happens in your program. And then it gives you where this happens. It's quite useful to have line numbers in your IDE in where your program, and then it tells you what the problem is. So for example, if I use a function that has not been defined, then it will tell me it's not defined, and that will then tell me, oh, okay, I either spelled this wrong or I forgot to make this function before I called it. So let's go through a few examples. And as I said, the most standard one is a syntax error. So when we just make typos, this happens all the time, and it's really irritating. But we have to be very precise in our programming. This is actually a little bit more tricky than the last one. So maybe try yourself, stop the program, try yourself figuring out how to fix this error. And I give you a few moments. So if you're coming back, welcome back. And now let's fix this together. So it's here in this line for I in range length DNA sequence. It's line 4. So this is this line here. We haven't got line numbers here, but that's fine. We can find this quite simply. So something isn't closed here. So intuitively, you would want to do this, but this doesn't work because, oh, we get another error. So that wasn't actually right. So what do we actually have to close here? And it's the length function. The length function, you cannot subtract 2 from a DNA sequence in a length function. That wouldn't make any sense whatsoever. So we can put the close parenthesis here, and now this will work. So that was relatively simple, but this is a typical example of a syntax error that everyone makes all the time. Another very common error is type errors, where you are expecting your variable to do something that is not defined for the particular type. So for example, here we have the type here is an integer, and here we're trying to add the DNA sequence, which is a string, to our integer. You cannot add you can add 2 strings, you can add 2 integers, but you cannot add a string with an integer. So this will give us a type error if we run this. And this will be a little bit more tricky to debug, but it'll tell us that it doesn't know which one is wrong. So it could be that DNA sequence should be an integer or ATG position should be an int. So this is a little bit a string. So this should be a little bit more tricky. You need to know the program to debug this properly. But you know that the problem is happening here in this line, and that there is a type issue. So you can check these types in Colab. There's a very nice way of checking all the variables and their types, and then you can decide. So let's change this here. What we want to do really is the length of the sequence here, which will, the length gives back an integer. So now we can run this. Okay, this was a little bit more tricky. And then another typical error is when you use the wrong names, when you get your variable names wrong. And this is happening here. So we used find start codon, but that's not correct. We actually call this, if I remember correctly, find atg, and then it will run. So for this, to debug this, you have to go upstream and see where is that function. You can look, use search in, or a find function to do that, but you have to be a little bit of a detective. A very handy way to deal with errors is to copy the whole thing with the error message and paste it into Claude or ChatGPT or Gemini, and they are usually immediately able to fix it for you. It's, again, it's probably not something I would do at the beginning. I would try it myself, and only if you can't find the error, I would talk it through with the models so that you learn something while you do it. If you just let the models take care of it, you will not learn anything. Um, there's one, so just some tips here. So read the error carefully, always find where the line is and think about what is the type of the error, and see whether you can get some ideas. It's quite, if you treat this as a detective work, it can be actually quite fun. And yeah, if you're in a hurry or later on, if you get annoyed, ChatGPT is really good at debugging your code, so you can get a lot of help here. One more thing to dive into briefly before we leave debugging is, how do we prepare for errors? So the type of error we dealt with was our own problems, where we just had a syntax error or we got something wrong when we wrote the program. But sometimes the data that come in are wrong. And if we just write a quick function to check something quickly, we don't need to worry too much about it. But if we run a program that we want to run again and again on various sources of data, we need to sort of think about the edge cases. In our case, for example, we don't want any sequence come in that doesn't have just ATGC. So a sequence that contains a character X or U or F is not correct. So that we don't want our program then just to fail or give us some nonsense information. We want to detect that and say, okay, there's something wrong with the data. And for this, I would just use a conditional and say, okay, if this happens, and again here, so I'm introducing some things that are a bit more complicated because I want to get you to read real code over time and get used to new things. So here the set is new, and here's a list comprehension that is new, but don't worry, the logic should be clear, but it's also quite good practice to go take that code that you don't understand and paste it into a model and let it explain to you. So this is a good way of learning how to deal with things you haven't learned yet. So it may be questionable to do this in a lecture, but I think it's a good practice because you'll come across code that you won't have seen yet. But here this should be relatively self-explanatory. So if there's only 4 valid bases, and if not, if the DNA sequence doesn't just contain valid bases but other bases, you get a warning and you return none, and then you start looking for ATG. So in this way, you don't start generating nonsense stuff. And this is a typical quality control program. So if you write a program like that, you have to really think of the edge cases and where could the data get wrong, and then write checks like that. In Python, there's an additional way of doing that, which is using a try and except statement. But this is not something I ever use when I write Jupyter Notebook code for my own data analysis, which is what you will do initially. This will become more useful when you write really stable software that other people use. And I don't think it's worth delving into try except right now, but you have heard of it here. And this concludes our debug session.